Today we're going to be learning 10.4 hyperbolas. For circles, ellipses, and other graphs, see our PowerPoints for Chapter 10 under the Confused Coyote project. But for now, we're going to show you how to graph a hyperbola, which is what trips most people up. So, this is taken straight out of your textbook, Advanced Mathematical Concepts by Glencoe and Harcourt. We are on page 645 in section 10.4, hyperbolas. And this is example number 2. So, let's start by having a look at the basic form of our hyperbola graph. It looks really confusing, but if you break it down section by section, it's kind of like a map. It's a map of a graph. So, let's start by looking at the form of the equation. Y squared over a squared minus x squared over b squared equals 1. Now, this is kind of how we map a box and then the hyperbolas. Our actual graph are these blue lines right here. This is our x and y axis, and then these are our graphs. And that's what we're really concerned about putting on the graph. However, for now, we just have to get this box down. So what is this graph? Basically, we have a lot of different elements. So on this map of our hyperbola, we have an x value and a y value. We have a transverse axis and we have another axis, which is called the so we need to start all of this over again. So today I'm going to be showing you 10.4 hyperbolas and how to graph hyperbolas. For circles, ellipses, and other graphs, you can see our PowerPoints for Chapter 10, but for right now we're just going to be working with a hyperbola. So, I'm working straight out of your textbook, Advanced Mathematical Concepts by Glencoe and Harcourt. This is page 645, example number 2. So, we're going to start with looking at the basic form of a hyperbola graph. This is in x first and y second form, but those can be switched, and I am actually going to show you a problem with y first. So in our x form of the equation, when you see x first, you know that the hyperbolas, which are these two blue graphs, are going to be opening onto the x-axis. So it's a horizontal equation. Now, let's look at the different parts of our graph. Our graph is like a map. All of our coordinates can be found up in this equation. So let's have a look at the equation as it relates to the map. Now, you know that this equation is going to have its center in the middle of the origin. That's because we don't have any values next to our x and y. And in regards to our origin, we're going to make a box. Each hyperbola graph has two axes. So we have an axis going diagonally this way and one going this way. What do these asymptotes do? These asymptotes, not axes, sorry, they're asymptotes. They show you where the graph of the equation cannot go. So if you have an asymptote right here and an asymptote right here, you know that your graph is going to never touch those lines. It's just going to expand like this. However, it's the same for the other side. So we don't have a graph vertically because this is an x first equation, but our graph never touches the sides of this x-axis. Now we have something called the main box. This is the main part of the map. The box is made up by a transverse axis and a conjugate axis. The transverse axis is on, in this case, the x-axis because it's a horizontal hyperbola. And the y-axis is the conjugate axis, which is just the other one. So it's on the vertical line this time. So on our transverse axis, we have the values for a. And a is 1/2 the axis. It goes on either side of your main center point. In this case, our main center point is the origin. And so we have an a value on this side and an a value on this side. For the conjugate axis, we also have a b value here and here. If you notice, in our equations, we have a and b there, so that will show you how big the box is going to be. So what is the point of this box? What is the point of this map figure? It's how you draw your asymptotes. So the whole point of the equation relies on the asymptotes to know where to go, and the asymptotes rely on the box to know where to go. In order to draw your asymptotes, you go straight through the middle point of your graph and through the diagonals of the corners of your boxes. So that's just a basic background on hyperbola graphs. Now let's look at our equation. We have changed it to make it complicated. So we start with y, which means this will not be a horizontal graph, it will be a vertical graph. So our hyperbolas are going to open up and down. And there are many different parts of this equation that we are going to have to get to know fairly well. So let's start by writing down all of our values. So we see that we have an a here. This is a squared. 36 equals a squared. So what does that make a? It makes a 6. So I'm going to go ahead and erase that. And we're going to write over here a equals 6. This is our b value. It's 25. So we know that b squared equals 25. Then our b is going to be 5. So we're going to go ahead and write that over in the given section. And we can find our origin by looking at the values inside the parentheses. Our x-coordinate is going to be the positive, or the opposite of whatever sign you have in here. So the original equation form is y minus the value or x minus the value. So you know that whatever sign is in here, the opposite will be true for the point on the graph. And so our x-coordinate is going to be positive 2, and our y-coordinate is going to be negative 4. This is the center point of the graph. This is where the map will be based on. So 2, negative 4 is our point of interest. And now that we have that given information down, all we need to do is plot these points on the graph. So in the graph of our equation, I'm going to go ahead and write that smaller so we have more room. We have y plus 4 squared over 36 minus x minus 2 squared over 25 equals 1. So on our graph, we know that it's mostly going to be vertical. Okay, let's make our box. So our box, we need to have a starting point of 2, negative 4. So let's go ahead and put 2, negative 4 on our graph as our middle point. Here's 2, here's 1, 2, 3, 4. So 2, negative 4 is right here. Okay, now since this is going to be difficult to graph, we're going to have to redraw our graph. Sometimes when you're doing pre-cal work, you're going to have to redraw graphs because you didn't know where it was going to lie in relation, and you don't know how much room you will have to work. So it's not a big deal if you have to cross out one graph and write another one, which is exactly what I'm going to do now. So the main thing for hyperbola graphs is that you keep things focused and that everything is clear, because if you draw your box incorrectly, then you're going to have problems. Okay, so here's 2, negative 4. 1, 2, 3, 4. Here's our center point of interest. Y-axis, x-axis. Now our transverse axis, the one with the A's, is going to be vertical. So our transverse axis will obviously lie on the xy plane, and our A value is going to be how far up or down that transverse axis goes. So we go 6 up from the point of interest, since A equals 6. So 1, 2, 3, 4, 5, 6. right here. This is our transverse axis. And then we're going to go down 6. 1, 2, 3, 4, 5, 6. Down this way. So, that's the first part of our box. The second part of our box is going to go left or right 5. So, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Go ahead and draw in those points. And you've made basically where your box is supposed to go. Now, all you have to do is connect the dots. So, that became our box. This is B, and that's A, this is A, and this is B, B, A, B. So, now we draw in our asymptotes. And this is going to show you where you're going to put your hyperbola. So, asymptote 1, asymptote 2. Now that we've drawn that in, we're going to have to figure out where on the graph our hyperbola is going to lie. So if it's a vertical graph, your points for your, and this is your transverse axis right here, this is A, and this is B, B, then you know your hyperbola is going to start where A ends and along your asymptotes. So if our asymptotes are wide like this, our graph is going to look like this. Oops, not kind of as silly as that. It's going to look like this, and it never touches the asymptotes, and it starts at A. It's more like that. Remember, drawing can get messy, so if you keep your boxes straight, that'll definitely help you. As you see, even I get confused on the drawings. So that is what your basic hyperbola, and remember the hyperbola never goes below this point right here on your, it has to go all the way to A. That's all you have to do to draw a hyperbola.